Hello, this short video will show you how to apply the outlier rule to the simulation app. The first thing that we'll need to do is to identify the success and failure. Here the success is paroled yes and a failure is paroled no. We also need to specify the probability of a success, which goes in this box here, and that's going to be 0.593. Our simulation is going to be constructed under a fair situation for the Native Americans. So under a fair situation, we should have seen 59.3% of those individuals receiving parole. There's a total of 59 Native Americans in our investigation, so the sample size here is going to be set to 59. We're going to want to select the count button from statistic. We have previously been working with the left side of this app. We're now going to use the right side of this app. The right side allows me to quickly and easily obtain many repeated outcomes under this situation. So for example, if I select 1K here, I'm going to be obtaining 1,000 statistics or repeated outcomes from this investigation. If I continue to hit the 1K button, I'm now up to a total of 5,000 repeated outcomes. Now these repeated outcomes represent what it would look like if paroling was done fairly. I know that because they're centered around 35, which is the expected outcome when paroling is done fairly. The lowest possible number for being paroled is 0, and the highest possible number on our number line is 59 here. Now, I'm going to apply the outlier rule by just putting in a value here in this box provided here. So I'm just going to make a guess at 28 being kind of an outlier rule. Now we have to decide what end of the distribution that I care about. And as I've already said, we care about the left tail of this distribution because values too low would indicate discrimination against Native Americans. So I'm going to want to select left tail here. In the staring example, we were interested in the right side or the right tail of the distribution. So I'm going to want to select right tail in that example. Okay, so when I use 28 as my threshold value from separating the unlikely values, which are indicated here in red, from the likely values, which are indicated in blue, I can see that I have about 4% of the observations are identified as being unlikely here. 4.24%. 212 out of the 5,000. Now I can move this value around. If I move this down to 26, for example, that's going to move this threshold value lower. So I'm going to have less of them being identified as outliers here. Or if I move this value up to, say, 29, I'm going to have more of them being identified as outliers. The outlier rule uses a 5% level. So we want this quantity right here to be as close as possible to 5%. 29 is a little bit too high here. Okay, so 29 is a little bit too liberal of an outlier rule. If I bring that down a little bit to 28 like I had initially, that's about 4.24% or so. So that is a good threshold value that we could use to separate the likely values from the unlikely values. So we would use 28 as our outlier rule for this particular investigation. Okay, thank you.